Welcome to Shifting Left on Production Excellence with Observability. We've come a long way. The past decade or so of the DevOps movement has given us tools and strategies so that now we can automate much of the work that used to be manual and error-prone. We're catching things like build issues long before they have a chance to hit production, and we no longer have to wake people up in the night just because of a sudden increase in traffic. We have auto-scaling and failovers and other strategies to make our systems more resilient. So what's the next step? We've already gained so much, but there's still more we can do. Well, the business wants to move faster. There's a need to respond quickly to changes in the market, as well as to ever-evolving data security and privacy requirements. But we as engineers have been burned so many times that we avoid taking risks. When we're nervous, our instinct is to hit the brakes, to say, please stop changing things, and that's totally understandable. But it turns out the velocity that everyone wants, it requires tight feedback loops, because it doesn't matter how fast you're going if you're pointed in the wrong direction. In software, we already have a number of feedback loops to help us see how we're doing as we write code and as our changes go out. But there's so much more that we can be learning about our systems. Hi, I'm Shelby Spees. I recently joined Equinix Metal as a site reliability engineer. Before that, I worked as a developer advocate at Honeycomb, where I engaged with an incredible community of DevOps practitioners. As much as I got to help folks learn about observability, I learned even more from people's experiences in the field. The biggest lesson I took away from all that work was this: we need to shift production left. Production is the feedback loop that I'm here to talk about today. When we talk about shifting something left, we're moving it earlier in the development cycle. The term became popular in the testing community. The idea is that catching and fixing errors early is cheaper than catching and fixing errors late. If you want to read a bit more discussion on the term, this blog post from Lisa Crispin is a great introduction. So when I say that we need to shift production left, what this looks like for developers is that we're thinking about production up front. We want to think about how each change will behave with real users and real data before it's even written. It not only helps us build better quality software, it also helps us recognize where to focus our engineering work to best align with the needs of the business, not just for this quarter's goals, but for the long haul. One question that frequently comes up is whether developers should be on call. It's true that if we want to benefit from the feedback loop of production, going on call for the software we write is very effective. But it's critical that we're not setting ourselves and our teams up for burnout, especially because production is increasingly complex. Modern distributed systems evolve such a huge range of technologies and skill sets. No one person can hold it all in their head. On top of that, traditional monitoring tools can be downright inscrutable. They're speaking in the language of individual hosts, but they can't tell you which part of the application things are going wrong. This is true even for the most seasoned ops engineers. You're often making in-the-moment decisions based off a correlation between a blip in the graph and whatever you can find in the logs around that timestamp. Plus, even for the most experienced people in the room, pattern matching only takes you so far. And that's because production is always encountering new issues. In part, because we've done such a good job solving for so many known failure modes, what remains are these novel emergent failure modes. Things where there's rarely a singular root cause. It's not just the latest change, it's often the latest change interacting with some change from 2 months ago or 2 years ago. And maybe it only appears on certain kinds of traffic. Or maybe there's some external dependency that's changed and now the ground has shifted beneath us and we have to scramble to update our own stuff in response. Stripe's 2018 report found that developers are spending 42% on their time on bad code and tech debt. Our teams are always fighting fires. We're constantly in this reactive state, and so we can't make forward progress. We can't invest in improving systemic issues. When something needs to be upgraded or migrated to a new system, new technology, it takes forever. And that really hurts trust between software teams and business stakeholders because our estimates are always wrong. Meanwhile, our heroes are exhausted. There's a few go-to people we rely on to keep things running, but they're so busy holding things together that they don't have time for knowledge transfer. As Netflix engineer Lauren Hochstein tweeted earlier this year, intuition doesn't scale. So we maintain this low bust factor. It makes our socio-technical systems fragile, and our people get so burned out that they end up leaving their jobs, even jobs they loved. It's a huge waste all around. This is why all teams need production excellence. Every software team deserves to have a healthy relationship to their systems in production. Production excellence isn't just what technologies you're using, and we already know that you can't buy DevOps, right? Whether the currency is dollars or an engineer brain cycles. Even adopting the most promising tools doesn't guarantee better outcomes. Instead, production excellence is about investing in people, culture, and process. Because the people building and operating your software systems, they're the lifeblood of your organization. My teammate at Honeycomb, Liz Fung Jones, would often say that observability should be like Gundam, not Skynet. The tools aren't there to replace us, rather, they're there to enable and empower us to apply our expertise as software practitioners. That's why production excellence is business excellence. You want to invest engineering effort where it'll have the greatest impact for the business, not just for this next quarter, but for the long haul. This is your North Star, your guiding principle. So what's the first step? Start with observability. Let's level set a little bit. Observability is the ability to inspect and understand a system's internal state using the telemetry data it's already generating, even if that internal state is something you didn't ever anticipate. This isn't about going in and flipping your log level to debug in production. Debug logs now don't help you for the incident that started 30 minutes ago and then inexplicably resolved itself. Observability also isn't about going in and adding new timers around the blocks of code that you think might be introducing latency and then deploying that change. You don't want to deploy between asking your question and getting an answer. You want to be capturing rich data all the time. It's not that debug logs and new timers aren't important or valuable. They just don't give you observability into what's already happening in your systems right now. Observability is for the hard to debug problems, those emergent failure modes I was talking about. You can't know which dimensions, which attributes are going to be important someday. You can't possibly predict that in advance. In distributed systems, it's often hard to identify the upstream change that's triggering downstream issues, especially when there are so many moving parts. When you instrument for distributed tracing, you can actually follow an individual trace and isolate the relationship between the upstream change and the downstream impact on that particular request. And then you can query to look for that pattern across all requests to validate your conclusions. If you're running into latency issues, it can be hard to identify where to introduce performance improvements. Identifying bottlenecks is a lot easier when every single event tracks its own duration. First, you can tackle the big easy wins, like finding the redundant API calls and eliminating them, introducing some caching and memoization. You want to do that before you start going in and benchmarking your sorting algorithms, because that might not even be the problem. And what if only some users are experiencing issues? This is a sort of thing that gets lost in our pre-aggregated averages and distributions. Observability tooling makes it cheap to capture lots of dimensions at write time, and then we can slice and dice and filter down that data at query time. Here's what that raw data looks like. This is an example event. It includes the sort of data that we often see in flat logs, but parsing those logs is finicky and expensive. Labeling our attributes makes querying much easier. On top of that, we can link events together into a trace. Each event has an ID, and it can point to another event and say, hey, that other event was the one that called me, that's my parent. It behaves like a directed graph. Now at runtime, you can capture data from across all parts of the stack, from the build ID to the user agent to which payment processor was used in that particular checkout transaction. Was it PayPal or Stripe? All of this data is worth capturing because technical decisions are business decisions. Let's talk about making the business case for production excellence. It can be difficult to map engineering effort to business impact. Anytime we want to invest in refactoring or paying down tech debt or introducing a new language or technology, there's always that question. How will this drive the business forward? Service level objectives, SLOs, help us define what success for our particular service means according to the business, and they help us measure it with our system telemetry throughout the lifecycle of a customer or a user. They act as a common language between engineering and business stakeholders because we think about events in context, ones that have customer impact, things like homepage loads, API requests, user queries. And since we've already instrumented for observability, it means we're already capturing lots of data within these user flows. That's why observability is the foundation. From there, we can define a service level indicator, which looks at each event and determines whether it's good or bad. The SLI service level indicator has a threshold, say that a successful homepage load should complete within 500 milliseconds. The SLI determines whether it meets that threshold. In this case, if it was successful and fast enough, it was a good event. So that's for individual events, but in order to measure risk, we need to look at the overall behavior. For events relevant to that SLI during our time window, what % of them should be good? And we want to use a rolling window, not calendar months, because if you had an outage on the 31st, while your customers still remember that pain on the 1st and 2nd and 3rd of the next month, you don't want to wipe the slate clean. You need to keep that in memory. So here's an example SLO. 99.9% of homepage loads in the past 30 days should be fast enough, according to our SLI threshold of 500 milliseconds. That's the goal that we're trying to maintain. It can be difficult to measure this sort of thing using traditional monitoring data because they're calculated as averages or distributions minute by minute, but not all minutes are equally important. Traffic patterns can change seasonally or even throughout the day. For example, Uber Eats probably cares way more about midday hours in North America when people are ordering lunch than they care about 5 a.m. over here. The other thing is that minute-by-minute SLOs can make it hard to measure things that happen intermittently, like deploys and background jobs. With our event-based SLO, we can track how we're doing over time on a graph like this. So you might be asking yourself, why 99.9%? Why not 100%? Well, a good SLO keeps your users just happy enough. Aiming for 100% perfect reliability doesn't make sense when oftentimes our users are running in unreliable environments. You can work your butt off to try and get 6 nines of reliability, but your users are never going to notice if they're on a mobile connection that only gets 3 nines. So that effort is better spent developing features that your users will love. Once we have our SLO defined, that allows us to calculate our error budget, how many bad events we're allowed to have in our time window, in our 30-day, for example, window. A 99.9% SLO target gives us an error budget of 0.1%. So for instance, if I have a service that serves about 1 million requests per month, and I'm aiming for a 99.9% SLO target on that month, that means I can have about 1,000 events fail during that month. Just like with a financial budget, the error budget gives us some wiggle room, which we want in case there's some sort of problem outside of our control. Here's a graph that shows us how we're doing, how much of our error budget is remaining, again on a rolling window. So on this same window as our SLO, we have about 62.3% of our error budget remaining. This data helps us have conversations about things like, when is it okay to take risks? If you are having a high reliability period, if you have some extra error budget, now's the time to perform some experiments. Release the chaos monkeys or release some experimental features. Because hanging on to that extra error budget, it's like keeping extra cash hidden under your mattress. It's a missed opportunity. Conversely, you shouldn't be performing experiments when your error budget is tight. If you've had a lot of recent customer-facing incidents, or if your engineers have been getting paged a lot, even if it's not directly impacting customers, your team is probably feeling burnt out and spread thin from all that firefighting. Rather than launching a brand new service, now is the time to invest in reliability and paying down tech debt. You'll see that investment reflected in your SLO data, and because we're measuring things that are impactful to the business, it can help facilitate future conversations with business stakeholders. This is what it means to make data-driven decisions about reliability and about risk. Speaking of getting paged, another powerful thing about SLOs is that they enable us to filter down our alerts to what's most meaningful. We need alerts to be actionable. Just because some particular system metric crosses some particular threshold, that doesn't mean it's necessarily something that needs to be fixed right now. When you get an alert that says disk is over 90%, well, we're running in the cloud nowadays. We don't need to dive in and swap out hard drives anymore. The auto remediation strategies we spent the past decade implementing, they've solved this for us. Unfortunately, it's our alerting that hasn't caught up. But here's how we can do better. For our earlier SLO example, we can see how fast we're burning through error budget. We can set an alert not just when we hit a threshold, but when the burnout rate is too high. So at this time, the line gets super steep. We're burning through error budget really, really fast because we probably have a lot of bad events that are happening all at once. That sounds like an incident. That's worth waking somebody up for. Soon after that, our incident responder is able to come in and mitigate the issue and return us to our previous, more modern burn rate that we see at normal traffic levels. With SLO alerting in place, we can be much more confident about deleting our old alerts because we know that our error budgets and our SLOs are aligned with business priorities. Does this sound like something you want for your team? Let's talk about how to bring production excellence to your organization. First, you want to take some time to explore. Your systems and teams are unique. There's no one way to develop an observability practice. Plus, this is a pretty new topic in software engineering. So make some space during this initial period so that your team can learn the ecosystem, develop your skills, and take inventory of the tools and data that you're already capturing and already have access to. You also don't want to do everything from scratch. There's auto-instrumentation libraries that can do a lot of the initial heavy lifting to get you rich trace data for HTTP and gRPC requests. OpenTelemetry is a CNCF project, and it's the effort of many community members as well as vendors who are investing in a shared tracing specification that's great for distributed systems. But if you don't have access to make code changes, you can also start by instrumenting your builds. My teammate at Equinix, Amy Toby, developed OTel CLI using the same specification so that you can add tracing to shell commands and build scripts. This allows you to observe your builds and find ways to speed them up, because CI is another one of those critical feedback loops for us as developers. I also recommend finding a champion and a sponsor. One or both of these people might be you. For your champion, find someone with a strong sense of ownership, a technical leader who really encompasses that DevOps mindset. They live in the code and they live in production. Your sponsor should be someone in upper management who can establish production excellence as an organizational priority. They can give your initial team space to do that necessary exploration and learning and help communicate the impact to other stakeholders. While observability is about capturing rich data all the time, your initial instrumentation efforts probably won't cover many things that's specific to your domain or your application, so fill in those gaps as you go. You're also probably not going to come up with the perfect SLO. You want to learn and iterate and use those feedback loops to once again learn more about your systems. Once your initial teams have gotten comfortable with their observability practice, now you can make it scale. Look for opportunities to factor out org-wide defaults as instrumentation libraries or config as code. This way, each new team has a shared foundation to build off of, and then they can customize things as they incorporate knowledge of their own parts of the system. And prioritize developer experience. Part of production excellence is making your internal tooling easy for people to use and adopt so that more people can come in and help respond to incidents and fix issues and also find new creative ways to deliver value. So the less friction there is for new developers to adopt an observability practice, the more success you're going to see getting buy-in from new teams. Finally, I want to talk about the next generation developers. More and more software developers are graduating from remote CS programs and boot camps, or they're self-taught. I myself went back to school for an online CS program that I didn't finish, so I'm both a college graduate and a college dropout. We're at this point in the industry where we're starting to see a generational divide. Where do we get more production engineers? Well, we have to grow them. We have this opportunity in front of us to make operating software a much better experience for this new generation. With observability, knowledge transfer is built into the system. It's built into our telemetry and our tooling. And with production excellence, we don't have to have the new generation live in on-call hell. I know that was a lot of information, so if you can't stay for the discussion, don't hesitate to reach out with questions on Twitter. That's the best way to reach me. Thank you so much for joining me for this talk, and remember, you got this. You deserve production excellence.
Great, thanks for that, Shelby. So now we will kick off with some Q&A. So one thing I was wondering is that when people are going through this process of implementing observability, what do you find are some of the common roadblocks they might run into and how to get around those?
Yeah, definitely there's a lot of different things. I think the biggest one is just the amount of like new terminology and just like new data formats and stuff that people just haven't been exposed to before, or people who've been doing ops for a long time, they might be new to things like, distributed tracing and like structure event data. And so that's something that I really cared a lot about when I was working at Honeycomb, was just helping level set for everybody, because this new form of observability, it's or this new term observability, it's new for basically all of us in software engineering.
Mhm.
um and so definitely, I can share out some resources in Discord to help people get started with just wrapping their heads around, what are we even talking about, making sure, as you start trying to use open telemetry, and as you start trying to share this with your teammates, you can sort of be on the same page talking about it. Another thing that can be difficult is, even once you've gotten a lot of people on board, it's hard to, like, make time for it. A lot of the time, there's usually one champion, that one person who really gets it and is really excited about it, and they're working nights and weekends to instrument their code and roll things out, across different services, and that's not really fair or sustainable. And so, finding that senior leadership who can really sort of sponsor this, and who really, supports the effort and cares about reliability, for the long haul, can make this more of like a company wide initiative, or at least like a department wide initiative, where you actually have the time and resources to get started on this stuff.
So is it if someone wants to improve their observability, but they don't quite have that complete buy-in from a champion and sponsor, is there still any way to kind of make some quick wins there, or do you suggest you really have to have those things to make any progress?
Yeah. That's a good question. I would say, the biggest quick win, and I mentioned in the talk, the biggest quick win that I saw in a lot of teams is instrumenting your builds. It's really fun. Um, to just, like, see, like, "Oh, wow, I didn't even realize that took so long." I've been in the position of having to debug other people's builds, and just, I don't know what any of this is and why these tests are failing randomly, and this was years ago, and at the time, I would have loved to be able to, like, trace and just, like, find the specific thing that was going wrong. And so, that's a thing that especially people who don't have access to code, or who are in environments where you might not be able to add random, I don't want to say random, but add new libraries, new SDKs, on top of like your like on your deployed code. You might be able to go into the build config and try it out there, or even just try it out like locally, to see what's going on there, because you'll learn a lot. And then the other thing I would say is if you do have access to code, but you're not ready to go through like the PR stage of getting everyone to agree that yes, we do need all this tracing stuff. You can still learn a lot just from sending data to your observability tooling from your local dev environment. I learned That's basically how I learned like how Rails works under the hood. It was just like doing all this stuff that I never thought about, because the instrumentation for Rails is like really, really rich. And so that's, I think, something that's very fun for devs who, especially if you're like a very visual person or if you've ever had the feeling of just you want a print statement for like every single line, but like going through like a debugger and putting like what do they call? I forgot the word. Um, stopping at every line is like painful. But if you can grab the state as of each event as it's running, it's really really insightful, and you can really learn a lot about your code that way. And so I find that to be really fun, and you can like share an example with your teammate and be like, "Whoa, did you know this was doing this?" Like, and start those conversations, and that's another way to get the ball rolling.
Okay, sure. Um, so I wondered, do you have any examples you could share where observability really made a big difference in delivering business value?
Yeah, I can share a link. I think there are links to it. At OllieCon this year, one of the keynotes was from a principal engineer at Vanguard, a large financial firm, and he actually got promoted because of his work on observability and reliability at the company. And so it's just a very cool story of this well established, um, enterprise firm adopting these practices. I actually got to sit on a game day with Christina. Gosh, my coffee is still kicking in, and I'm just so bad with names. I should have written these down. Um, Christina at Vanguard. I'll get all the links and all the names and everyone. But she ran game day, after setting up tracing, on a few different services, and just watching all of this, like all the people who are experts in those services, but brand new to tracing, brand new to observability, and they were able to like connect the dots in real time, what they saw in the data, like to what they knew about their code. It was this just really cool example of like real time like consensus and like knowledge coming together. It was like just very very cool. And so I feel like Vanguard's a great example of adopting observability as a priority.
Hmm.
uh yes, that's exactly who. Thank you, Paul. um and and yeah, and so I think that's like a really cool example because um like they did all of the things I talked about. They had their internal champions, they had sort of they were eventually able to get leadership buy-in, but they also did this sort of like grassroots, let's figure things out on one team and learn from it and iterate, which was really, really impressive.
Great. And how do you see people in DevOps and developers? How do you see people reacting to these changes in observability? What sort of changes in the workplace seem to go along with that?
Yeah, there's certainly like the like, do we need this? We have monitoring, we have our graphs, and I hope that like I understand how the desire to like maintain that expertise, and I think it's very, very valuable, especially at the systems level, to be able to debug from monitoring data. But I also think that for the majority of companies, the majority of teams who are running mostly at the application layer, and who are more likely to be stopped by third-party API calls than they are by like anything close to the middle. This is this thing. Um, and so I think helping or like for senior folks who have a lot of experience, to help sort of bring bring this forward and bring this to their teams and use it as an opportunity. This is the other thing I really am excited about with observability is because it's almost like it's like a cross between commenting your code and writing unit tests. It's runnable documentation, right? It's your when you instrument your code well, and when you do it in a way that it's both, it can be verbose in the way logs are, and it's queryable in the way metrics are and the way structured logs are, and you also get all of your timing data, your latency data and stuff. And so having all of that as like one chunk, one source of information that you can like later on go in and slice and dice and filter and zoom in on and zoom back out and look for patterns. Now like your the stuff in your head about how the system works, because you know that there's this weird quirk in the Go compiler that always does this with this kind of string or whatever. I don't know anything about Go. Um,
Mhm.
that can now live in the code, and it's a pattern that you can now not even in the code, but in your observability data. It's a pattern you can now query and link to, and you can include it in your incident reports and investigations, and you can link to it in Slack and your Jira tickets and like all these sorts of things. So now you no longer have to like sit down and explain these weird quirks that happen in production that aren't really reproducible locally. You can just point to the data. And so I think that's like the biggest, most valuable thing about observability is it's knowledge transfer, like built into your code and built into your runtime production telemetry.
Mhm.
Um, and so I think that's very, very powerful for teams. And it's why I talked about like the next generation of developers there at the end is we don't um like when I first started doing DevOps work and working on infrastructure and owning like the deploys and Jenkins, all of that stuff, like I would I was learning it all from scratch. I was kind of thrown in the deep end, and so I didn't have years and years and years of exposure to these failure modes that everyone else seemed to already know about. It was very, very frustrating, and I was just like, I want to help, and I don't know what you're talking about, and I can't learn it fast enough to be useful. Um, and, I would see an alert and I would SSH into prod and I would pull up my dashboards and I would, follow along in Slack and I would like look over at my teammates and there was like nothing I could do to like make sense of it. Except like, do that for 5 or 10 years and, we don't have the time for all of the sort of new, the cloud native, the self-taught, the bootcamp grads, all of this new generation of developers and DevOps folks to sit around and learn from exposure. We need to teach them faster. We need them to learn faster. And so I think observability is the way to do that. Sorry, I rambled a little bit there.
No worries. So, do you think that there's a pretty clear line between observability and regular monitoring, or do you think it's more of like a fuzzy sort of spectrum?
um this is this is going to be addressed very thoroughly in the O'Reilly book that's coming out early next year from my colleagues at Honeycomb Observability Engineering.
Okay.
But the difference between observability and monitoring is monitoring, you're doing the math at write time.
Mm.
You're calculating your averages and your distributions when you write down your data. And observability, and this is sort of in practice, that there's a fuzzier
Hmm.
like observability is the ability to understand and inspect anything ever inside of your systems or whatever. Like that's not meaningful enough. The difference in practice is that monitoring is pre-aggregated, pre-calculated data. Observability is you calculate on the fly when you query.
Hmm.
When you ask, I want the P95, I want the distribution, I want the show me the heat map, visual distribution of all of this, so I can see the shape of the of our traffic. And so that's what it means to have observability in practice. Um, and there are different tools that offer these abilities. I am a little bit biased towards Honeycomb because I worked there and I love the tool. But the important thing is that you can calculate new calculate basically like new calculations, new
Mm.
aggregations on the fly, things you didn't think of. Yes. Yes. Yeah, and so in practice, what this looks like with monitoring is uh, you normally wouldn't want to um, add tags, for example, for user ID, because then you have a separate like time series for each user ID. Um, and that becomes very expensive and a lot to store, and it starts to defeat the purpose of why we do time series in the first place, which is because it's very compressed and it doesn't take up much space and it scales well. But if you're not at the point of like Google or Amazon traffic levels and Google or Amazon like data collecting, you can get by, and it's become a lot cheaper to store that raw data in these structure event formats in this JSON format, so that with modern observability tooling, you can now say like, hey, I wasn't I never thought to break down on user ID before, or on like some different payment processors, or, just show me all my AWS availability zones,
Mhm.
or things like that that wouldn't have been relevant at any point before that, but are suddenly relevant because, oh, it turns
Mhm.
out there's an AWS outage on one availability zone and not the other ones. And that was actually an incident that happened at Honeycomb.
Mm.
And we were able to migrate traffic over within like 5 minutes. The person who got paid, it was, like, the first time they got paid in a long time too, and so they woke up and they looked and it's like, "Oh, it's just, this one availability zone that's failing, everything else seems fine. That looks like that's what's the problem. Migrate traffic over." The Amazon status page hadn't even updated yet,
Mm.
um, and it wouldn't update for several hours after that. And so that's the sort of thing where, like, you have to respond to what's happening in reality
Mhm.
and not just what, like, the data you think to collect beforehand is going to tell you.
Mhm. Okay.
That's the big that's the big difference. I
Mm.
get really excited.
That's excellent. Um,
Mhm.
so what are some of the signs that someone could look for that their organization in particular might benefit from observability?
Absolutely. Um, Certainly if you're running distributed systems, or even if you're running like something like a Rails monolith, but you depend on external services like Redis or payment processors, or that's like my go-to example. Or uh, any sort of third party library or tooling or SaaS provider, where yeah, where you're dependent on other people's like reliability,
Mm.
right? Um, the question that would often come up when I was responding to those incidents as a baby DevOps engineer was just like, is it a us problem or a them problem?
Mm.
And even just being able to answer that,
Definitely.
it's like, is this something that we can solve, or is this something that, our people are gonna talk to their people and they'll figure out some, like, contract, negotiation because they guarantee this much reliability and they failed, to reach that. And so, that conversation's above my pay grade, but, it's this sort of thing, like, is this something we can fix, or is this something that, like, all we can do is update our customers that we're having a hard time? And I think with more and more of us, depending on shared service providers like Cloudflare and Fastly and AWS and Heroku and Netlify and all this stuff. They have yep, they have excellent they have excellent reliability. Um I'm not trying to like instill like fear, uncertainty, doubt right now. It's more just like you wanna know what you're working with.
Yeah,
And most of the time it is an us problem. And then you also in those cases, you also have way more, useful data to use to respond.
sure. Yeah, that makes a lot of sense. Thanks, Shelby.